In the previous lesson on HACCP Principle Number 1, we learned how conducting a hazard analysis systematically identifies and evaluates all hazards in a food process and begins to determine what control measures will handle these hazards. The 5 steps of hazard analysis led us towards determining whether a hazard was reasonably likely to occur. For every hazard that is likely to occur that was identified in the hazard analysis, there must be one or more critical control points where the hazard will be controlled. After studying this lesson, you should be able to describe the requirements for determining critical control points. You should also be able to apply a decision tree towards identifying critical control points. Last of all, you will be able to document your findings on a HACCP summary form. Let's begin by defining critical control points. A CCP is a point, step, or a procedure in a process at which it is essential that a control is applied to prevent, eliminate, or reduce a hazard to a safe level. A CCP can control more than one hazard at a time. For example, cooking steps often destroy more than one type of pathogen. CCPs are chosen based on science-driven decisions, and they are sometimes mandated. For example, the FSIS has a requirement that there will not be any fecal contamination at the point of slaughter. Okay, so how do we go about determining whether a processing step qualifies as a critical control point? Sometimes this decision process is easy, other times it's confusing. Fortunately, there's a commonly used tool that's designed to help us with this process. This tool is called a decision tree. Let's take a look at a decision tree that I found in the FDA's guidelines for the principles and applications of HACCP, which you also have access to on their website. Using this decision tree is very simple. We start with the first question. Does this step involve a hazard of sufficient likelihood of occurrence and severity to warrant its control? If the answer to this question is no, then it is not a critical control point. However, if the answer to this question is yes, we proceed to question 2. Question 2 asks, does a control measure for the hazard exist at this step? So again, we answer this question, and this decision tree helps us to determine whether we need a critical control point at this step. If the answer to this question is yes, then we go ahead to question number 3, and so on. Here is another example of a decision tree. You'll notice this decision tree has 4 questions, whereas the last decision tree only had 3. Different scenarios will call for different decision trees. Some decision trees are better for some processes than others. As you go about developing your HACCP plan, you'll find the one that works for you. A common question in HACCP projects is whether we should place the CCPs near the beginning or towards the end of a process. Occasionally, the best time to control a hazard is at the hazard's point of entry into the product or the process. An example of this is when an allergen cleanup is required. If you waited until the end of the process to screen for the presence of allergens in a product that is not supposed to contain allergens, you could end up with thousands of pounds of product for rework. Alternatively, if you place the CCP at the beginning of the process, you could catch allergen cross-contamination prior to ending up with so much rework. Also, consider the application of metal detection immediately after a particularly hazardous process, such as those utilizing bandsaws that are likely to chip saw teeth later in the process. Usually, however, the CCP will be placed as late as possible in the process, so there is a terminal treatment that will cover multiple hazards, such as the effect of the cooking step on biological hazard. The most common CCP is a step which provides thermal destruction of pathogens. This is also one of the most effective in that it actually eliminates the hazard. Most pathogens will not grow appreciably at refrigerated temperatures below 5 degrees Celsius or above 57 degrees Celsius. This leaves a temperature danger zone which reaches from 41 degrees Fahrenheit to 135 degrees Fahrenheit. Food which is likely to support the rapid growth of pathogens should not be held within this range for more than a short time, usually defined as more than 4 hours. Therefore, rapid cooling of a cooked or processed food through this zone is important. Other CCPs may be similarly effective, such as the addition of acid to reduce the pH or the incorporation of chemical preservatives. The last point of this video is to mention that the choice of critical control points is recorded on the HACCP plan summary form for clear presentation. As with the hazard analysis summary form, factors for making decisions should be documented and maintained with the plan summary. In summary, now you should be able to describe the requirements for what makes a critical control point. And you should be able to apply a decision tree for determining critical control points. And last of all, you should be able to document the findings of your critical control point identification on a HACCP plan summary form.